and perpendicular lines. Come on, that work to do. So we talked about parallel and perpendicular lines. And what did we say about parallel and perpendicular lines? Who remembers?
Parallel lines have the same slope, and perpendicular lines have opposite reciprocal.
I could not have said that better myself, so I'll say that again, louder for everybody to hear.
Parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes.
Exactly. So having said that, did anybody run into a difficulty with any of the homework problems? Okay. Let's talk about which one you had trouble with. So who had one? Miss McDowell. 47. 47? Get on the page. How about that? Okay, 47. Okay. A commercial jet airplane climbs at takeoff with a slope of 3/8. Okay, so here's the airplane heading off this way. And the slope of this line is 3/8. Right? Now, what do we know? How far in the horizontal direction will the airplane fly to reach an altitude of 12,000 feet? How far in the horizontal direction will we fly to reach an altitude of 12,000 feet? Now, what is another way to think about slope? I mean, I know you've got your formula. Okay. We can think of slope as rise over run, right, kids? So in this problem, what's the rise? 12,000? What's the run? X. So rise over run is the slope of the line. So one way to do the problem is to simply set up the slope fractions. Rise over run equals the slope. How do you solve something like this? So 3x equals, oh boy, 96,000. So dividing by 3, x equals 32,000 feet. Now that's one strategy. If that one makes sense to everybody, we won't talk about any others. Does that make sense to you? Rise over run is another way to think about slope. All right, who else? Anybody else? Harry?
51.
51. Okay, so I have a table with a bunch of values in it. Write a linear equation using the points 1998, 5.9, and 1999, 6.3. Write a linear equation. What does that mean? Write the equation of the line. And what do I need to write the equation of a line? I need the slope, so I'll start with the slope. So that's 6.3 minus 5.9 over 1999 minus 1998. So that slope is just 0.4 over 1. And then, Harry, I got a choice. I can either do point slope or slope intercept. Which do you like best? slope-intercept. So y equals mx plus b. I can use either point. I'll just go ahead and use this one because the numbers are smaller. So 5.9 equals 0.4 times 1998 plus b. I'll let my trusty calculator help me out here. 5.9 equals 799.2. So 5.9 minus negative 793.3 is my b. So this equation, Harry, should be y equals 0.4x minus 793.3. So that's part A. Use the equation. All right, so that's my equation now. Use that equation, right here, this one, to estimate the expenditures in 2002. Now, I want you to stop and think about something for a minute, all of you. When we wrote this ordered pair, this was the year, and this was the money, right? Because it was $5.9 trillion. I don't even know what it, I mean, trillion is so huge, but $5.9 trillion. So the ordered pairs represent the years and the money. Now they're telling me that the year is 2002, and they want me to find the money. So this could go into the equation where? This number right here. Where would I put that in my equation? That goes in as x. So the money, y, will be 0.4 times 2002 minus 793.3. So using my calculator, I got 7.5 trillion dollars. Okay? Now, what does the next one say? Okay, then I'm not going to do the next one because it's exactly the same. I would just put in 2006. And then it says, superimpose a graph of the linear equation on a scatter plot of the data. Now, do you know what a scatter plot is? Okay, so that would mean just take the information, the points they gave me. So this would be the year, and this would be the money. So they gave me 1998, 99, 2000, 01, 02, 03, and so on, however many they gave me. And then I have 5.9, 6, 6.1, whatever. And then I just start putting these points on here from the table. Then they say, okay, so you got this bunch of points just scattered out of here. Now take this line and graph it. So graph that line right on top of that. And what should happen if I did this? If we have time, we'll do this on the calculator. But if I actually did this, what should happen?
Most of the points would be on or very near the line.
Exactly. So hopefully, my scatter plot data, they're not going to all be on that line, but hopefully the line is, as you said, very close to most of them. Yeah, does that make sense to you, all that stuff? Okay. All right, very good. Who else? Anybody else have a question about one of the homework problems? Okay, so tomorrow, just a minute. I know, I see your hands up. Tomorrow, if I walked in and said, take out a half sheet of paper, we're going to write the equation of a line parallel to this line, everybody would be able to do it? let's practice real quick just to make sure. And I'll just do that problem. I'll say, okay, write the equation of the line parallel to 3x plus 2y equals 7. 3x plus 6y equals 7. And containing let's say -2, 4. So the directions say write the equation of line. So since you all know how to do this, somebody tell me how to start.
Get y by itself the first one.
Take the equation you've been given and get the y by itself. Somebody besides Julian tell me why I am doing this. To find the slope, which is -1/2 x, or -1/2. Once I get y by itself, I can tell what the slope of this line is. And the slope of this line is -1/2. Now, here's the key word in the problem. What does that tell me? No, parallel. What does parallel mean? Same slope. Think about parallel lines. They have the same rise over run. So I'm going to use a slope of -1/2. If this word had been perpendicular, and it certainly could be, then the slope I would use would be +2, because I flip it over and make it negative. The negative reciprocal if the word's perpendicular. If the word's parallel, I use the same slope. Now what do? Your job is to write the equation of the line. You have figured out what the slope is. What do you do now? You pick how you want to do it. Either do slope, point slope form, or slope intercept form. So Trey, which way do you want to do it? We know we got a slope of -1/2 and we got this point. Which method do you like best? You like this. All right, so here we go. Y equals mx plus b. -1/2 times -2 is not -1, +1. So I got 3 for my b. Which means, what do I write down and put a circle around? Y equals -1/2 x plus 3. Perfect. All right. Ashley, what's your questions?
43, but the B part?
Okay, it's exactly what we just did, except you use the opposite reciprocal slope. So I would do everything I just did, only instead of using -1/2, I would do the opposite reciprocal, which would be +2. Turn it over and make it negative. Whatever the slope is that you got for part A, flip it over and make it negative for part B. All right, so everybody understand what might happen tomorrow? All right, get your note sheets out. What? All right. Today, we are going to begin a very important section. It's the section on solving equations, namely quadratic equations. There are lots of ways to solve quadratic equations and other kinds of equations, not just quadratic, but other equations. One way that will always work is graphically. So how many graphing calculators do I have in the audience today? Some of you just aren't getting it. You guys, this is a requirement. You have to be able to do this. So if you don't want to buy one, okay, then check one out from the library or something, because you have got to have it. That's all we're going to talk about today. It's tonight's homework is on the graphing calculator. And if you are just sitting there watching, you're not getting the most out of it. You need to be pressing the buttons with us and getting the feel for it. So here's what I need. Hold it. If you have a graphing calculator, hold it up. All right, look, we got two in a row right here. You guys are amazing. You need to get yourself around somebody that's got one. So move to some place where somebody's got one so that you can see what's going on. Now, again, I want to emphasize there's more than one way to do this, but we're going to be looking at problems that where graphically is the easiest way. Not necessarily this problem, but certainly some others. So, here's what I need you to understand. When we say we're going to solve graphically, what we mean is wherever this thing crosses the x-axis, those are the solutions. These numbers, the X-Intercepts, also known as zeros. These are called zeros, okay? X-Intercepts or zeros. When we solve an equation, we're looking for its zeros. So whatever you see on the picture, we're going to graph this in a minute, whatever you see, you really only care about where it's crossing the x-axis. There will be other times when we'll care about, oh, how high does it go, how low does it go, but not now. If we're solving, we're looking for where it crosses the axis, okay? So we're going to graph this. Now, we talked about this the other day. Do you remember how to put an equation in? What button do you press? The very first button on the calculator that says y equals. Now, I already have an equation in there, so I have to hit clear to get that out. Right? Now I'm going to put this equation into my calculator right here. So I press 2. Now, how do I get the x? I get it from my variable button, which is the second button in the second row. It has an x on it. It also has a t and a theta and an n. Repress it and we should get an x on our screen. Did you? Now we want to square that. The easiest way to square is just hit the squared button. If you have an x squared button, just hit it. So now it says 2x squared plus 5x. And again, where are you going to get the x? Your variable button. And then minus 3. Now before I graph this, I'm going to go to my window. And would you make sure that you have a standard window? Does anybody remember what that is? We talked about it the other day. Anybody have to remember? X min, -10. X max, 10. Y min, negative 10, y max 10. Your scale, just leave it at 1. Now, hit graph. Do you see a picture that looks like this?
Yeah.
Now, these are the points that we want to see. Those are the points that we care about. For some equations, including this one, some of the points are pretty obvious. For example, you see the little hash marks on your axis? When you said x scale was 1, that means those hash marks are all worth 1. So it looks like this point is at negative 3, doesn't it? And that's great. The other point, though, looks like it might be somewhere in between a couple of hash marks. So that one's going to be a little harder to find. So I'm going to tell you how to find those points. Okay?
Mine says,
Of course it does, because you either typed it in wrong or you have the wrong answer. Yeah.
Laughing with you, Lindsay. I'm laughing with you.
I haven't checked it, but I really don't like
Okay, now, everybody pay attention because we're going to find this point right here. Oh yeah, that's what they're there for. Almost always, you are not going to be able to tell what the point is by looking at the graph. You're going to have to use a special feature of your calculator. So everybody ready? All right, here's what you do. This is the point we're going to zero in on right here. This is the point we're going to look for. Everybody's looking for this one. All right? Divine, this is big. You maybe have never done this before. I need you to press second calc. And calc is in the top row of buttons. It's right here. It's actually written in blue. Oh, my calculator is blue. Above the button, above the trace button. So you press second calc. Now, there is a whole bunch of stuff that's available for you, but the very second one in the list says what?
0.
So click down with your arrow button and press enter where it says 0. Now, what does the calculator say now? It's kind of asking you some questions. What does it say?
Left bound.
Left bound. Here's what you need to do. Do you have a cursor flashing on your curve?
Mm-hmm.
Okay. You need to move that cursor so that it's somewhere over here to the left of the point you're looking for. So just have the cursor flashing over here somewhere. Anywhere over here, and press enter. When you pressed enter, you should have seen a little like marker thing come up on the screen. Now what does the calculator say? Right now. So now we're going to move our cursor so that it's somewhere over here to the right of the point we're looking for. So just move your cursor. Anywhere over there is fine. And when you press enter, it throws up another marker. Now what does it want to know? Oh, so where do you think the 0 is? Well, I think it's right there. So I'm going to move my cursor as close as I can get to this point. You may not be able to hit it right on, and that's fine. Just get close, press enter, and down at the bottom it will tell you the 0 is where x is 0.5. I have no idea. I know how to use TIs, I have no idea how to use it. If you bring in your handbook, maybe we can sort it out from that. But I've never had one of those calculators, I don't know how to use it. I know that calculator will do what we're talking about. I just don't know. If you have a handbook at home, do you have a handbook? Okay, look under zeros, finding zeros, and that will tell you how to do it. Okay. Now, just for practice, we already can tell what this one is, but let's do the same thing with this one and see if we indeed get -3. So, who remembers the steps to find that second 0? What do? Second calc, and then what? Go down to 0 and press enter. And then what? Move the cursor. Now kids, if this is the point we're now looking for, where does the cursor need to be if it's left bound? Over here someplace? Alright, so we'll move it over there. And then it needs to be down here someplace to the right of that point, so we'll move it down here. And then I'll move it up there as close as I can. And sure enough, -3. Just like you guessed.
I figured out how to find it.
Oh, awesome. All right, let's look at the next one. And I'm going to wander around and help those of you that have calculators if you need help. Now, first of all, you can't do this yet. What do we have to do to this equation? We got to get a set equal to 0. So x squared minus 8x plus 15. Now, I know there are other ways to do this problem, but we are practicing graphically right now. So we're going to put this equation into our calculator. So what do we do to put an equation in? We hit y equals. But you already have this one in there, so you'll need to hit clear and then type this one in. All right? So those of you with a calculator, I'll come around. Are you guys watching what she's doing?
That's my I thought she was going to go all the way down. She said she was going to do anything. Because I thought she was going like, we were going to sit there. Yeah. You know, it's going to start moving straight. But, you know. I was like, stop it. I hope this that's fine. Should you that's a little that's why you go down to 0. And then up to 0. Move it to like where the thing yeah, I know, left part is down. There you go. Right now, I don't Do you, Taylor, do you really? you do the second hour.
One day.
No, I had all 10 hours of sleep this week. About 6. Night of the game. Wake up really early to get home. About 4. You know why they do that? Get up. Well, so you get up and also so really tired Saturday. So when you sleep, it's like that.
Which I did. I slept all day Saturday. I did anything Saturday.
Get out!
I was so worried about us getting I was so worried about us.
He knows
What?
What just happened?
So I just put that on.
Dude, are you kidding me? I'm not worried about it.
You just said that. Wait.
you know.
That's the same.
Ready for home game?
Valerie. You guys got this?
Here.
Anybody got this figured out?
No, I didn't.
Tight ends this week.
The other side. Where the second then you can enter again.
And
Okay,
5 is the other.
now, everybody who's got a calculator is getting this figured out, and that's great. I want to talk about a couple of more situations, but first let's look at the sheet real quick. I don't see any need maybe to do both of these, but I do want to talk about them. C, what would you do on C before you go to the calculator and type it in? You distribute. So you'd have 3x squared plus 11x equals 20. And then you would minus the 20. And then you can go ahead and type it in your calculator and do everything that we just did, right? Now, I don't want you to do that because I have 2 things I want to talk to you about. Oh, before I do, D. How would you start D? Subtract 25. It would have to look like this in order to put it in the calculator, right? And then you do everything the same. Now, here are the ones I want to talk about. They're not on the sheet, but they're important. What if you had this equation? I want you to graph that on your calculator right now. Graph it and tell me what is different or special about it. It looks the same. Oh my, what'd you say, Lindsay? It does not touch the x-axis. It's a nice little parabola, but it doesn't touch the x-axis. Now remember, we're supposed to be solving. And when we solve, we're looking for where it crosses the x-axis. So what does this tell me? There's no real solution. Do you remember the imaginary stuff from last year, the eyes and all that? That's what would happen on this one. Okay? Now I want to give you one more. what if the equation looked like this? Ay, ay, ay. How do you even do that, she says, on your calculator? Well, let's go to y equals. We're going to put this equation in. Let's take out the other equation that's already in there. Now, get your x. You know how to do that. That's your variable. Now, one way, the fastest way to get that cube is to hit this button. So you already have x in there. Hit this button, which is right over here under the clear on my calculator, and then hit 3. This is your raised to the power button. So this says x raised to the 3rd power. And then you can put in your 3x squared. Oops. And your minus 7. Now, did you get a parabola like you got for all the rest of them? No. But you got a weird squiggly. Does it cross the x-axis?
Yeah.
So that's what you're looking for. So you're going to do exactly what you did before, but this time there's only one answer, right? Because it only crosses one time. And that's the point you're looking for. Is there any question about that? All right, tonight's homework is very short, but it's all graphing on the calculator. So those of you that don't have one with you, try to borrow one or get one somehow so that you can do tonight's homework. All right? Tomorrow we will have a quiz that will have nothing to do with this. It will be what we talked about, which is what, Red Bob? What's tomorrow's quiz? Or perpendicular. It could be perpendicular. So the quiz will be write the equation of the line parallel